Today, we're going to go over enabling mapping in Tableau, connecting and working with spatial files and spatial joins, editing unrecognized locations. We're going to talk about density maps, expanding Tableau's mapping capabilities, creating and sharing custom geocoding, building and analyzing polygon maps, understanding Map-box integration, and creating background images. So, when working in Tableau with map data, often you are going to have to connect with spatial files. And there are a lot of different kind of spatial files out there. There's shape files, there's map info tables, KML, Geo, JSON files, Topo JSON files, and Esri files. And there's even more out there. And depending on what kind of, where you're pulling your data from, you are going to get different options on which file type you want to connect to. These are just some of those file types that Tableau can connect to. Now, when connecting with file types, they look a little bit different than files that you may be used to. Depending on where you're downloading them from, you'll get different file options. In this case, I'm going to data.gov in order to download a shape file of the different Burbank areas trees that are in the Burbank area. So in this case, they give me a zip file that is a shape file that has lots of different information in it. And that information in it can look differently than what you expect. So I'm used to columns and rows in Excel myself, but shape files are a lot different. So if you try to open up a shape file just from a CSV or an Excel file opener, it won't work how you expect it will. And it may not work at all. And then the information won't be clear. I tried it once and it just looked like an unlegible script. And that's because it's broken up into different ways. There's text files, there's DBase files, tables, and there's shape files. And the shape files are what Tableau is showing and connecting, and these are kind of behind the scenes for us. So when connecting to a shape file in Tableau, there's two ways to connecting to shape files. And we're gonna do a bit of a jump. So there's two ways you can connect to spatial files in Tableau. You can either join one spatial file to another spatial file, or you can join a spatial file to a non-spatial file using latitude and longitude fields. So for an example, we are going to look at what this looks like in Tableau when we connect a non-spatial file to a spatial file in Tableau. So this is the data source pane when you're inside Tableau. This is where Tableau is always going to start you when it's connecting to a new data source. And in this case, I've connected to two separate data sources. One, I've downloaded that shape file that we discussed that we saw online. And then I also downloaded a Chicago crimes data field. The shape file that I downloaded is actually bigger than the one we saw that was Burbank's. This is Chicago's. I went across the US and made my way to Chicago and downloaded a shape file. And this is Chicago crimes data. These two files are completely different. This is a shape file right here, and this is a rows and columns flat table file that I'm used to working with. But until I want to visualize data from both of these two files, so I need to make a join out of the two. I need to connect the two files. And the way that you connect two files is one that is not a spatial file and one that is a spatial file is you need to create a new calculation in the file that is a flat file, a non-spatial file, and create a calculation that turns its coordinates into a spatial file. So you do this by, when you create that initial connection to create that join, it's always going to give you a Venn diagram to click into. Inside of that Venn diagram, you go to the file that is not a spatial file. In this case, it's a Excel file that I'm working with. And you're going to either edit or create a join at the bottom of that field. And one of the calculations Tableau has inside of it is make point. It's a spatial calculation. It has 5 different spatial calculations that we're going to go through today that turns a non-spatial field into a spatial calculation or works with a spatial calculation. So in this case, we have longitude and latitude of crimes that occurred in Chicago. So I'm using this calculation called make point, which will make the location, the latitude and longitude, a point on top of a map. And once I use make point by adding this longitude and latitude, I click OK, and I connect the geometric side, the geometry side of my shapefile to the new calculation that I've created. And in the intersection of that shapefile and the point that I've created, there is going to be a join. It's going to connect my latitude and longitudes to the latitude and longitudes that falls within a shapefile. Okay, so once we have created that join, we are good to start working with a file as if it's just a regular Excel document that you're working with inside of Tableau. All right. So I would like to take us to our PowerPoint. Now, once we get a file that we can use inside of Tableau to analyze map data, there are several different spatial functions available for us to use. There is area, make line, make point, distance, and buffer. And we're going to see examples of each one of these spatial functions, which are calculations that we can use within our maps in Tableau. So the first function is area that I want to go over. And what area will do is it will take the shapes that you have, the geometric shapes that you have in your files, and it will give you the space within those shapes based off of whatever criteria you want. So, well, it depends on if you want miles, if you want inches, if you want kilometers. You can get the space from these geometric landscape spaces, and you can get the area within them using this area calculation. And this is exactly how you would type it out in Tableau. You would write area, and then you would choose the geometry field that we've seen a couple times now, and mile inside of quotes, and it will tell you in miles the size of these shapes, which is very, very useful and flexible. You can also use 2 other calculations. One is make point and one is make line. So we saw an example of make point when we joined the 2 data sources, when we pulled the latitude and longitude and made a comparison with our shapefile. So that is an example of make point. With make point and make line, you can create visuals like this one, where you can get the distances from, not the distances, the travel, it's a form of distance. It's a distance. You can make a line from one place to another. The difference is it's not giving you back a distance, it's giving you back a line. And in this case, the lines that come back are actually curved lines. They curve along with the shape of the earth. Often these make line calculations are used with data that is travel data. So you're going to or from using airports. Make line is very useful. You can also use it across states and across cities to say, how far am I from one location to another, or make a line from one location to another, so you can compare the length of lines to see distance. But this isn't a measure of distance, it just creates a line. And this calculation, this table right here was used using very simple formula. And in this case, the formula that was used is, well, I thought I had it here, but I guess I may have clicked away from it. Here it is. just slightly clicked away from it. The formula that was used to create that chart that we just saw was a combination of make point and make line. So when using the formula make line, you actually enter 1 point, the latitude and longitude of 1 point, and the latitude and longitude of another point, and you can make a line between them. That's why data that has a to field and a from field is very useful. So you can either create your to or from field, you can have a field, in this case it's destination field in your data in order to use these make lines charts. Along with make line and area and make point, there is also distance. With the distance calculation, you can find what falls within a specific distance of a point. So in this case, this chart uses distances to find out how many casinos are near the Mandalay Bay Resort in Las Vegas based off of distance. So using the distance calculation, you can see how many casinos one could get to from the resort within a certain amount of miles. And it's very flexible. It's just using one calculation, and you could see that as I up my distances, more points fall within this distance and fall within my chart. So you can create flexible charts using these formulas, many different kinds of charts using these formulas depending on your end need. There's also another field called buffer. Buffer is similar to distance, being as it will choose a circle around a location, but instead of showing what falls within that circle, instead buffer will actually give you a circle. So in this case, you can get you'd see if there were stores near each other based off of buffer. If they were within 3 miles of each other, you wouldn't want to build a store there. So you can build a buffer visual map so that you can see what doesn't fall near another location, and therefore build stores that aren't right next to each other using a buffer. So those are the 5 calculations available to you in Tableau to look at your spatial data and analyze your spatial data differently. All right, so when it comes to analyzing this spatial data, Tableau's spatial data comes in several different ways, so you may want to analyze it in different ways. We are going to move back to Tableau. There we go. Now, the types of spatial data there are in Tableau are point geometries. So all of them are geometries. They're either points, they're line, or they're polygon shapes. The point geometries, in this case, we are looking at a point geometry, and it is giving us the location of trees in Burbank. So each one of these dots right here is a tree inside of Burbank, and it's a specific point. And we got this point by using this field geometry. It's what pulls in all these different points. And as I zoom in, I can zoom in to specific trees. They don't show me the trees. They aren't the trees itself. They're not tree shaped, but they're the point where the tree is. And so you can analyze this data. You can make the tree bigger or smaller or change the color based off of what kind of information you want to analyze. But what we have been given here with this is a point to analyze. There's also line geometries. So in this case, we got the stormwater pipes in this area. So you can see that all these, I'm going to zoom out a little bit so you can see it a little bit easier. And then we're going to zoom in. That was the opposite of zooming out. So this has mapped all the storm water pipes in this area, okay? And as we zoom in, we can see that each one of these pipes is a line. So the shape file that was given gave directions to build each one of these lines here and where to place each one of these lines on my map. And now I have the ability to analyze this information, these lines. I could even join this information to non-spatial data that gave us things like community area, that gave us weather patterns, and see if the location of these stormwater pipes are relative to weather issues we've seen in the area. The last type of geographic field that you can use in Tableau that's available in a shapefile is a polygon shape. So in this case, we're looking at coral reef. And we could see the different coral reefs in this area. And these shapes are not like the trees, which were just points, circles, different than the lines that we had with the stormwater drains. This is a unique, almost undescribable shape. Every shape is a little bit different. So this shapefile gave a bunch of polygon directions. It says go up, go left, go right until you create this kind of polygon. And so now I can analyze these reefs using this shapefile here. Using these unique shapes. So I can click a point and I can look at radius. I could use the area that's filled in here. I can use the different distance between these locations. I can create a line between these points. All these are possible with the formulas that we just went over inside of all these different shapes, whether we're working with points, with lines, or with polygons. Now, let's talk about working with our files in Tableau. When you first connect to a spatial file in Tableau, what you'll notice is at the bottom of Tableau in your data pane, you'll have fields called latitude and longitude. Whenever Tableau is working with maps, it automatically gives you a latitude or longitude. If it recognizes any of the data in the field as a geographical data, like state and zip code and city, it's automatically going to give you longitude and latitude. With this longitude and latitude, you can begin to build your maps. All I have to do is go in and double-click latitude, double-click longitude, and Tableau gives me a map. It knows that we are going to be working with maps and spatial data, so it gives you the map right up front. In this case, we are working with a data set that's kind of like a big store that sells office supplies. And so we have lots of different cities across the US in which this store sells office supplies. So if I wanted to see the cities in which my office supplies are sold, I just need to double click on the dimension that I'm interested in, the geographical dimension. In this case, it's city. And Tableau will populate the different cities in my data set. So this is fantastic. Wasn't hard to do. And you're going to find that once you've made that join with your shapefile, your data, it will be quick to work with longitude and latitude. Tableau is very functional with maps. But issues can arrive when working with maps. In this case, with my city, I ran into 343 unknown cities in my data set. So if you have unknown cities in your data set, all you need to do is go up to map and you can edit locations. Now it's good to know your data, so when issues like this arrive, you're able to, you know the data well enough to make changes. Say, okay, these are null. Someone forgot to enter something. I can make some changes, because sometimes that just has to happen on the user's end. Sometimes you can just type it right in their Excel, but other times you got to go in and do some heavy duty work, like in this. This time, the reason that our cities are unknown to Tableau is because they are ambiguous. There are multiple locations that a city could be. I live in Columbus, but there are multiple Columbus is in Ohio, and I didn't add a state field or a zip code to go with this. So it doesn't know how to identify these different cities, where to place them, what state. So in this case, you would go up to this edit locations, and you can say, hey, get your additional information. In this case, it's state information from a field called state. So by entering state information, you can make it, by placing state there, you let Tableau know exactly what information is needed. But we still have 83 issues. The reason that we still have 83 issues is because we're working with bad data. There are multiple cities and states with the same zip code information. And Tableau sees that in here, and it has an issue with it. So sometimes you need to connect to a clean data set or make a join with a clean data set in order to clean up your data, a data set with the longitudes and latitudes of your information correct. So in order to connect to that data set, you would go up to Map, and you would go Geocoding and import Custom Geocoding. So if your data is dirty and it needs to be cleaned, you can connect to a clean set of data, maybe with clean set of zip codes by state, by city, per each one of your sales, so that you no longer have unknown locations. But Tableau doesn't always make it so clear that locations aren't known. So you have to look down here and say, okay, I'm missing data. How do I find it? And going up to Map, and either by connecting to your custom geocode locations or by editing the locations physically yourself, you're able to pinpoint the different locations of your data, make sure everything is known and you're not missing out on any information. Now, there are also many different ways to display your data. So Tableau will display your map data in many different ways. And one of these ways is density maps. So the map types that we had just looked at were all different from density maps because they had very defined lines. With a density map, you don't have those defined geographical lines any longer. It takes the geographical information and it looks at how close they are together in order to get a density map. So in this case, we're looking at a density map of a cholera outbreak, and we're comparing two separate kinds of data. So in this case, we see those, oops, didn't mean to click, but we see spatial data right here, the locations of the different cholera outbreaks, much like we saw the trees. But now we see this heat map, this density map in the middle that's actually showing us where the center of all this lies. So it's actually moving away from the geometrical shapes that you're used to seeing on maps and actually looks at the intersection of the coordinates in order to create a density map. So you can actually layer map information on top of each other by using these different mapping options available to you. All right, the last but not least, oh, excuse me, trying to get back to our PowerPoint together. That is all the mapping options available so far in a 30-minute period available to you in Tableau. I wanted to see, did anybody have any questions about mapping options in Tableau?
Well, thank you so much for that very informative webinar, Brandy. We are going to get to those questions in just a few moments, so we want to remind our attendees, keep those coming. But first, I am going to pass this over to Karit, who is going to be telling you all about some fantastic promotions that we will be offering all of you guys on today's webinar. So go ahead, Karit.
Thank you, Tracy. And I hope you are able to see my screen now.
Yes, we
And
can.
great, thank you. Welcome all. I hope you had a very fantastic session with Brandy, and I'll just love the information that she shared so far with us. My name is Kirit. I am the marketing manager for NetCom Learning, and I will be showcasing you few of our Tableau offers we have right now on the NetCom Learning webpage. All you need to do is, if you're interested to know more about the Tableau offerings, you just need to go to our webpage, netcomlearning.com, and choose Tableau from the list of vendors mentioned below the search bar, which will then take you to our Tableau authorized uh, vendor page, which will give you information on different types of courses we have, the types of certifications, and also various resources like blogs, upcoming webinars, and press releases. You can also reach to the resource section through the through one of the pages on top through the for the webinars, blogs, case studies, and ebooks. So when you click explore all, it will take you through our product page, which contains a list of products we offer for Tableau, which is Tableau Analytics, desktop, and server, along with the trainings and certifications associated with the Tableau training. I will not go detail into this, but I would like to show you one of the training courses for desktop training courses and the Tableau accelerated offer we have right now running. So the training desktop training courses are basically into three levels. The first is the desktop 1 fundamentals, desktop 2 intermediate, and desktop 3 advanced. So anyone who is opting to go for a Tableau certified data analyst certification, the prerequisites are that you need to complete the desktop 1 and the desktop 2 training. So what exactly is the desktop 1 and 2 accelerated course offer we have right now? The main advantage of the accelerated course are two. There are two main advantages of it. The one is the time saver, and the two is the cost effectiveness. As the name suggests, it is an accelerated course. That means it is a fast paced 3 to 5 day course which will take you through a comprehensive Tableau training for desktop 1 and desktop 2. Again, based on the classes running, that is, if it is a full day course, it will not take you more than 3 days to complete both desktop 1 and desktop 2 training. And it's a half day course, it will not take you more than 5 days to complete the desktop 1 and 2 trainings. And below are the schedules mentioned. And based on these schedules, you can pick and choose based on your convenience when and how to attend the class. And remember, these schedules will be changing on a monthly basis, and we'll be updating these schedules, dates, and times on a monthly basis. The second advantage, like I mentioned, is the cost effectiveness. Traditionally, if you go for desktop 1 and desktop 2, the cost of both is more than uh, the one mentioned here on the accelerated page. So simply stating, accelerated course is nothing but the cost effective, fast paced learning training course for you to attempt the data analyst certifications. You can also request for a group training wherein if you have learners, if you have a team of more than 10, you can request for a customized group training offer that our learning consultants will reach out to you and create a customized plan as per your requirement. In case you need any more information for on this accelerated training, you can always fill up the form and someone from my team will reach out to you and clear your queries as per your requirement. In addition to this offer, we also have various other offerings called as NetCom Plus, which is an unlimited training subscription, and something called as NetCom 365, which is our exclusive learning portal. The information of these are present in the handouts which have been shared with you. Request you to please look through that and hope you will take advantage of all the promotions and offer we have and help and partner with NetCom to be a part of your learning journey. With that said, all the best for your learning journey. Happy holidays and thank you. Back to you, Tracy.
Great. Thank you so much for all that valuable information, Karit. And as we mentioned before, Brandy was asking about some questions, and we have time for a few quick questions. First one comes from Dennis. This is for you, Brandy. Where can I find additional Tableau mapping examples?
The best place to go to is Tableau Public, tablewpublic.com. And so if you will venture with me, Tableau Public. So Tableau every day chooses a viz of the day that they are that they choose as their favorite visualizations created. So here are several vizzes of the day right here, and you can see many of them are using maps. So I would say go to tablewpublic.com or just Google Tableau Public visuals or maps, and you'll get lots of great examples. But they post up one every single day, and often they include maps because maps make people happy.
Okay, here's another one, last question we have time for. What are the recent updates to Tableau mapping?
So one of the recent updates to Tableau mapping is the ability to add layers. Let me see. Oh, one of them is actually to create compare XY coordinates and use longitude and latitude to map out information. So you can actually turn your longitude and latitude information to like an inventory, to a storage facility. Also, many of the things we went over, buffer and distance, are within 2 years as well within Tableau. So they're constantly making updates to mapping abilities.
Great. Thank you so much for that, Brandy. And before we sign off, we are going to launch a quick poll to find out how many of you might be interested in taking some additional training. So in addition, we do have a lot more informative webinars coming up. So please go to netcomlearning.com/webinars in order to register. And we want to thank you all for joining us today. And if you do come up with any additional questions, feel free to send them to us at webinar@netcomlearning.com at any time. We hope that you found today's webinar informative, and we look forward to seeing you back here with us soon. Feel free to tell your friends and colleagues about our webinars and other courses. Have a great day, everyone.